Well, good afternoon. Today we shall discuss elementary results regarding binomial theorem. So, what is in fact the binomial? So, any expression containing two terms is known as binomial. So, any expression, let us say, of this nature, any expression of this type x plus a, that is called a binomial. Similarly, an expression containing three terms, that is known as a trinomial, and I will be discussing in this talk very few results. The first one is the binomial theorem for positive integral index, second is binomial coefficients, and of course, a very interesting thing regarding Pascal triangle. So, these are just simple definitions and remarks that you take an expression which contains just two terms, that is known as a binomial. For example, you take a plus b, 1 plus ab, 2x plus 3y, and so on. Similarly, an algebraic expression containing three terms is called a trinomial, and so on. You can write down this. For arbitrary terms means expression having more than 3 or 4, that in general is known as the polynomial. So, before I go to define the binomial coefficients and Pascal triangles, I will recall, will all of you know, that is some notations. The one is NCR. What is NCR? NCR is defined as factorial n upon factorial r into factorial n minus r. So, this type of expression is binomial expression. These are simple notations, that is n C r, that is factorial n upon factorial r into factorial n minus r, where you define factorial n is equal to n into factorial n minus 1. Here one thing is very important, that is factorial 0, this is equal to 1. Well, factorial 0 is equal to 1, this is just a convention. There is no proof for this expression factorial 0 is equal to 1. Well, you may see, you may have seen in certain books, but that proof is not correct. So, factorial 0 is equal to 1 is just a convention of writing. So, this gives you from here, for example, if you want to calculate factorial 5, then this is 5 into factorial n minus 1 means 5 minus 1. So, this is 5 into 4 into 3 into 2 into 1, and that is use simple multiplication. So, that is 120. So, factorial n is defined in this manner, and this NCR, this is defined as, this is also written as sometime, this factorial n is also written as, this is same thing, and sometime there is written as in this manner also. So, this is just a matter of writing, there is no hard and fast rule. Now, what is NCR? What is this thing? NCR, in fact, you might have already done it, but I am just recalling it very briefly. This means if you are given n objects, and we have to choose r objects out of them, then these are the ways. For example, I give you a very trivial example. Suppose you have to appear in 4 papers. You are being examined in 4 papers. Then the very simple question I ask you, well, in how many ways you can fail in your examination? And answer to this is very simple, because if you fail in one subject, then by your notation, that is 4C1 means if you fail in 2 papers, even then you are declared fail, so that is 4C2. Similarly, 4C3, and suppose I fail in all the papers, then that is 4C4. If you calculate it, then you will get the number as 15. That is, if you have to appear in your examination, that examination is having 4 papers, the number of ways you can fail in that examination is 15. So, that is just a simple consequence of this notation. Now, next there are certain relations which are very important for these binomial coefficients, and the most important is NCR plus NCR minus 1 is equal to n plus 1 CR. This is very important relation, and the trivial one, that is NCR, is same thing as NCN minus R. Well, this is trivial, so I give you a very trivial proof also. This is factorial n this side upon factorial r into factorial n minus r. This still you can write as factorial n, because you want NC n minus r. So, this is your same thing as factorial n upon factorial r into, so factorial n minus r, you write it like that, and this is n minus r, you can write it. So, if you compare this with this expression which I defined just now, that NCR is factorial n, so r is being replaced by n minus r. So, this is nothing but the same expression, that is NC n minus r. So, this is a very clever remark. Now, I come to the main theorem. Now, to discuss that theorem, let us see a few expressions. Suppose I write x plus a raised to power 1, that is x plus a. Suppose I write x plus a square, then that is x square plus 2xa plus a square. Let me write one more, x plus a raised to power 3. This is x cube plus 3 x square a plus 3x a square plus a cube. Okay, you want to know what is x plus a raised to power 5. Now, we have certain observations that x plus a raised to power 1 is x plus a. So, the power is 1, number of terms is 1, 1, 2. In second expression, that is x plus a square. Well, the power is 2 and expressions are 1, 2, 3. So, 3 terms are there. Similarly, in case of 3, 4 terms are there. So, from these 3 expressions, you probably expect that x plus a raised to power 5, at least you know this will contain 6 terms. How many terms will be there? 6. I have not given you the proof, I can find out even x plus a raised to power 1000, but with the observation of these 3 let us say expressions, intuitively I can say that x plus a raised to power 5 will contain 6 terms, this at least I am sure. Now, if you look those things, for example, I once again rewrite this x plus a, this just to make you clear, plus okay, x square a plus, okay, I am leaving a blank over here, a square plus a cube. Now, here it was 3, it was 3. So, now what is happening? Power here is index is 3. So, the first term of x is x cube. Now, next time the power of x is decreasing, that is x square. Second time it is x, once again 2 minus 1, that is x raised to power 1, and here x raised to power 0. So, apparently it looks that power go on decreasing if you consider x. On the other hand, here power of a, that is 1, here is a square, that is 2, here is power 3. So, power of x are being decreased while the powers of a are being increased. Now, the question is how they are coming. So, this you can see by your manual multiplication, otherwise also you can calculate, which I will just give you the final result what binomial theorem states. You can write down these coefficients. So, for example, you were planning to write down power 5. So, you expect it will be something x raised to power 5 plus some gap I am leaving, the but power I am sure this will be x raised to power 4 into a plus of course x cube a square plus x square a cube. Here of course, here terms I have not written, I will write, I will give you the formula, plus x a raised to power 4 plus a raised to power 5. But these are the missing things like this. Here what will be there, it is to be seen here also. And apparently, you know, if you have seen the expression for x plus a square, x plus a cube, this coefficient is 1 and here is also the coefficient 1. So, you seem to be sure that the coefficient of x raised to power 5 will also be 1, the coefficient of a raised to power 5 will also be 1, and of course, with the help of your formula they turn out to be 1. Now, what are these missing coefficients? So, here where term I will write in by that language 5c1. Here the term will turn out to be 5c2. Here of course, which I have missed, here will be 5c3. Here will turn out to be 5c4. Now, you want to write over here also, so that will be 5c5. Here it is 5c0. And in fact, This is a trivial consequence of the definition that NC0 is of course NC n minus 0, which is n. By that formula NCR is equal to NC n minus r. This is equal to 1. This is always a trivial remark with the help of definition. So, if you write it completely, so that is 5C0 x raised to power 5 plus 5C1 x4a plus 5C2 x cube a square plus 5C3 x square a cube plus 5C4 x into a4 plus 5C5 a raised to power 5. Now, you can write down these values, you evaluate them by using the formula for NCR. You use this formula, once again I am repeating, factorial n upon factorial r into factorial n minus r. Using this formula, you will find out this as 1. So, this is x raised to power 5 plus, you calculate yourself, I think I am writing of course directly, this will turn out to be 5. 5C2, this should be 10 x cube a square, here also will be 10 x square a cube plus 5 x a4 plus a raised to power 5. So, this is my expression. Now, let us have certain observation regarding this expression. You see here the first term and the last term, means this way the coefficients are 1. You go over here, that is 5, and come from that side, means 5. So, these two coefficients are also same, they were same, and here is 10. So, they are also same, and that is the consequence of that result, that NCR is NC n minus r. So, once again I repeat all those process, that is number 1, this is just repetition and there is no need in fact, that if you are having x plus a raised to power n. So, in this expression there are n plus 1 terms, means if power is 5, then you will have 6 terms, power is 10, you will have 11 terms, and so on. Now, let me go back to really write down the expression for x plus a raised to power n. One thing is very clear, that you will have n plus 1 terms, and let me take the help of the sheet. So, okay, here I have taken a plus b raised to power n, that is the same thing, my a is x and b is a, which I have already discussed. So, whenever n is a positive integer, then a plus b raised to power n, you see that expression also, that the powers of a, as I gave you as a remark, powers of a, they are in decreasing manner. The first is a raised to power n, then a raised to power n minus 1, then n minus 2 and so on, and final is a raised to power 0. And the power of b, just to make you clear, I have written it b raised to power 0, otherwise it is 1. So, they are starting b raised to power 0, b raised to power 1, b raised to power 2 and so on up to b raised to power n. And the coefficients are very simple: NC0, NC1, NC2, NC3, NC4, NCn minus 1 up to NCn minus 1. And in view of the remark that NCr is NCn minus r, that is the coefficients which are at equidistance from left side or from right side, they will be same, because NC0 is NCn, NC1 is NCn minus 1 and so on. So, this is the statement of the binomial theorem for integral value of n when n is positive, and when n is negative, that will be discussed later on, but for the time being I am considering only this case. You can also write down it in summation notation, that is NCr a raised to power n minus r into b raised to power r is varying from 0 to n. That is the same thing, just where of course once again I am repeating, that is the same thing, NCr is equal to factorial n into factorial r. So, this is the complete statement, and these are known as binomial coefficients. Now, you see these triangles, while they are very interesting, if we write down a plus b raised to power 1, then a plus b raised to power 2 and 3, then these points which are written as 1 2 1 and so on, 1 3 3 1, 1 5 1 4 4 4 1 etc., and if you join them in that way, then they take the form of triangles. And the beauty of them is, for example, the first one you say, so 1 plus 1, that is 2, 2 plus 3, like that. So, they are known as, they are written in fact in a very systematic order, and next in figure you will see they are basically nothing but the coefficients of, let us say, in the expression binomial coefficient in the expression of a plus b raised to power n, and from here itself you will get so many things, because this 1 1 I have taken, this is for second case, this is for third line and so on. Now, you see the result which I have just proved, that is very very trivial and very clear with the help of this Pascal triangle, that is NCr plus NCr minus 1 is n plus 1 Cr. Though I have given you the proof also, but with the help of these, let us say, triangles, you can directly observe that the result is also true whenever you consider the binomial coefficients written in this very systematic manner. So, this is the result in fact which I have already shown to you, which I have already proved. Well, these are the same thing, repetition. These are in fact the coefficients. One is a plus b raised to power 0, second is a plus b raised to power 1, then a square, then cube and so on. So, well, this is the same thing which I have already mentioned. These are the observations. So, in fact, I have collected them just to make you aware and written, though I have already discussed them. So, this is n plus 1 terms, the expression a plus b power n, and everywhere a raised to power n, b raised to power 0. So, the sum of the powers, that is n plus 0 is n. In second case it is n minus 1 plus 1, which is once again n. In third case it is n minus 2 plus 2, which is once again n. So, you can conclude that sum of indices of a and b of each term in this expansion is nothing but n, which is the index of a plus b, that is a plus b raised to power n. And of course, this is also just simple consequence of the, let us say, remark which I mentioned in the beginning, that is NCR is equal to NCN minus R. So, this means the terms equidistant from beginning and in the end, or from left or right, they are essentially same. This is also some particular case, because my a you choose as x and b I am taking as minus y. So, you write down it as minus 1 raised to power r, NCR same thing, x raised to power n minus r, y raised to power r. So, the coefficient of x minus y raised to power n will be of this nature. This is also very clear, because if you find out, for example, the expression for a minus b square. So, that will be a square minus 2 into a into b plus b square. So, terms are alternately positive and negative. So, that is simple consequence. Now, this expression is very important. 1 plus x raised to power n is equal to NC0 plus NC1 plus NC2 plus so on. So, 1 plus x raised to power n, that I just wrote down there, that was your NC0 plus NC1 x plus NC2 x square plus NC x raised to power n. This is important. You see, these coefficients, they are also written as C0, C1, C2 and Cn. This is just the notation. So, this you can write as C0 plus C1x plus C2x square plus so on plus Cn x minus n. Well, I am intentionally giving this expression because I have written it is important. So, it should be really important, and let us see. Well, that is the special case of the binomial theorem of a plus b raised to power n or x plus a raised to power n. Now, let us do certain manipulation in this expression. What are those manipulations? This simple expression which is nice, C0 plus C1x plus C2x square plus Cn xn. This gives you lot of informations regarding binomial coefficients. And what are those? Let me see a few out of them. For example, I choose x is equal to 1. Suppose I choose x equal to 1, then that becomes 1 plus 1 raised to power n is C0 plus C1 plus C2 plus C3 plus Cn. So, this is my 2 raised to power n is equal to well 2 is not written properly. So, I take that expression and simply put x is equal to 1, I get a